My boys, we have a wonderful machine in our possession, having until we fully explore the full potential of this miraculous machine. We shall tell no one. Hello, welcome to the wonderful world of random sequencing. Today, we're going to be talking about 65 is equal to 513, and we'll be talking about the 31 is equal to 77 is equal to 27 is equal to 14. The reason why this is the case is because the 31 expresses 111, 3 ones, 111, which in binary notation is 7, and this is 7, and so you basically have 7, 7, and 7, 7. If you add them up, you get 14. So 2 7s expresses. 27 expresses two sevens, and 7 7. That's 2 7s is equal to 14. So that's a concept that you should be familiar with. Another concept here is the 35 plus 35 statement, which is equal to 70. In other words, these double zeros and this double zero is basically a statement. It says C as in seeing something, right? So if you see 35 and you see 35 over here, it makes two 35s, and that is equal to 70. So in other words, 35 plus 35 is equal to 70. So we're looking for a value of 70 here. So in other words, if these are zeros, right? So this has to connect within a half step somewhere. Here is going to be a 7, because there has to be a 7 that links to a 0. So as these sequences go by, and this is the last place where you express a 7, right? So in these kind of situations, it has to be a number that has a 7 of some sort, which means 7, 17, 27. So if you play those three numbers, one of those 7s is going to connect here to make 70. So that's it's an important thing to know. And remember, it's 35, 35, because this is seeing 35, this is seeing 35, so it equals 70 when you add them out, right? And so you're looking for a 7 here. It doesn't happen, and then finally you reach the last point here, and so you play all your 7s, 7, 17, and 27, and you'll hit. One other thing I'd like to talk about is this expression here, which is 80. It represents 80. And over here is just a statement. I think we could see it as a 20, and it's a carryover statement, just like here, and this is 90. So this is 80 here, and so if you multiply 5 times 16, that's 80. And so the 24, as you can see right there, is a multiplier. In other words, if you go ABC all the way to 24, you'll get an X. So this is the multiplier. It has multiplication functionality. So here you have your 80, right? And then 5 times 16 is 80. And here's your multiplier. And so one thing you want to note also is that notice these 2 zeros and 2 zeros. So they represent either 20, which is 40, or they're going to represent 02, which is 2, or 02, which is 2. And so you put those together, you get 22. So what happens is that these two expressions, like the 02 or 20, 02, 20, comes to this cell right here. That's just a half a step away. So this sequence and this sequence expresses both those. So in other words, if this is 20, 20, that would be 40. And if this is 0202, that'd be 22. So that's an interesting little sequence there. I'd like to talk about another concept here, and this is the 90 that's being expressed right here. The way that 90 occurred is that if you could see this expression here, it's a 5 linked to 24. Now if you throw that 5 underneath, you get a better picture of what's happening here. You put that 5 underneath and you get this right here. And so what's being represented is the statement here, which is 2. This is your statement. 2 what? 45s. So if it's 2 45s, 45, that will equal to 90. So that statement again is just 2 45s, and that's equal to 90. Another thing I also want to mention is that this 31, which is 111, in binary notation it's 7, and that's also 7. So this statement says 2 sevens, and 2 sevens is 7 7. 7 plus 7 is equals to 14. So this expresses 14. So again, if you ever get like a 31 linked to a 27, you probably want to play out a 31, because what happens is you'll get 7 7. That's 2 sevens, right? 7 7, and that will be equal to 14, or 14 like this. And this is the equals. In other words, in binary notation, the 3 is 1 1, so it's equals 14. One other thing I also want to talk about is the this 28 value here. And before that, you have the statement here. This is the I am. This is like the 3 is kind of symbolic for an M. So it's saying I am what? 28. So what is 28? 28 carries the statements 2 eighths, right? And 2 eighths are 8 8. And 8 plus 8 is equal to 16. So this is a very, very natural sequence, and so you should be very familiar. Remember the I am statement. It introduces a number that's a value number to be played out. And again, this is 28. It says 2 eighths, which is 8 8. 8 plus 8 is equal to 16. So that's very important to know. Another thing is this number here. It says, if you look at the 35 and 16, on the left-hand side, you have the statements of the value number. Statements of the value number. So this is a I am, just like this functionality here. I am what? 56. So that's the value that's going to be played out, because this I am statement is basically introducing kind of a theme. I am what? 56. So it's a number to be played out. And then over here to the right, you have a statement that says plus 2. So it's like it's saying to add 2 cells. This is the plus and the 2, plus 2. And if you look diagonally right across, so it's kind of all going this way, right? And then you have 28 plus 28. So 28 plus 28 is equal to 56. So again, you have your statement, right? On the left-hand side, I am what? 56. And then you have the plus 2, and you have the 28. One thing I also want to finish up with is that the concept of virtual memory, RAM, or random access memory. So virtual memory is basically what we have here, in the sense that when you see the statement C, the Z00 is the C, and it sees 35 and C35. So that's it's creating a 35 in virtual memory, or random access memory, and so that's an interesting little concept there. You should be very familiar with, and that's pretty much finishes up this whole sequence. And folks, as always, please click the subscribe button below, show some love, give me some thumbs up. I have links below with PayPal and Patreon, and I will see you on the next wonderful world of random sequencing.